So this is Archiware Webinar Wednesday, Digital Media Archival Best Practices with Archiware P5. I'm David Fox, working for Archiware, and the other voice you just heard is Thomas Waldinger in Germany. Hi, Thomas.
Hi, Dave.
So you are a P5 integration specialist. So
yes, I'm an integration specialist and system integrator. So I'm basically doing like consulting, setting up the installation, showing people how to work best with P5, or doing integrations with their mom system.
Okay, and you're normally in Spain, going by the ES domain, but you're currently living in Germany.
Yes, that's it.
And if people want to get hold of you based on what they're learning in the webinar, then that's your email address. We will, let me just flick to the next slide. We're going to record this session. So you'll be able to see this content on YouTube if you miss any of it, or if you have to drop out, or if you want to share it with any friends or colleagues. The GoToWebinar interface has a questions panel. So we're going to take 10 minutes of questions at the end of the webinar. We ran the same webinar this morning. It ran for 1 hour exactly, with quite a few questions this morning for the kind of European time zone. So yeah, it'll get recorded. The slides will get sent to you as a PDF by somebody at Archiware, so no need to try and write everything down. So let's actually get stuck in here. So in this webinar, we are going to look at what is digital media archival. Some of you probably have a good idea already, but we'll just cover over the way that we see that. Then we'll look at the basics by differentiating between a backup versus an archive, because those sometimes people think, oh, I've got a backup, so I don't need an archive. Not true. We'll look at the way that P5 handles storage, because obviously a big part of archiving is where are you going to put all those hundreds of terabytes of movies and audio files and so on. So the options there. Then the way that's configured in terms of specifics within P5, plans, pools, and indexes. So we're going to look at what those are, how they fit together, how you use them, plus looking a little bit at the P5 interface. The P5 Mini-MAM concept, this is being a Media Asset Management acronym, this is creating and storing previews and metadata. So we look at how we do that within P5, how it works, what it looks like. Then we look at how you can actually integrate the P5 archiving engine with a DAM that maybe you're already using, digital asset management or media asset management systems. Which ones work with P5, how to find out more about that. These are things that are using an API to talk to P5. Then we have the P5 Companion, which is a simple API-driven application that's part of the product, so you can run that on your Mac, Windows, and Linux desktops for drag and drop archiving. And then finally, we'll just end up with a little look at how you can set P5 up across cloud, on-premise, or a mixture of both. And then we'll take your questions at the end. So as says, questions, put them into the questions box as you think of them. And we won't answer whilst we're going through the presentations, but we'll answer them all at the end. Okay, so what is digital media archival? I've basically just phrased this in the way that I see it, really, which is to deliberately preserve valuable media files for the long term for commercial purposes. So people using a product like P5 generally doing it within a commercial setting. So there's a monetary need to hold on to these media assets for the long term. Long term means, decades, really. So it's an important thing to think about. Often it's going to be something that happens at the end of a project. Once a piece of work is completed, if you archive it, then you can remove it from your primary storage, but keep it accessible via a workflow. So what P5 provides is a workflow for input of assets into the archive, and also a simple way of being able to search, identify, and recover things that are coming back from the archive, and a flexibility over what kind of storage you can use to store. So that's what we see as being a digital media archival process. Anything you want to add, Thomas?
In the lifetime of your company, probably you might switch once or twice your DAM system or the target storage, because it's just like LTO gets new generations. There are new things like clouds coming up and all that kind of thing, but you still want to be able to access old files. And that's really cool if you can use one product which just adds the functionality for new stuff and still have the possibility to access your files 20, 30 years back in time, you know?
Yeah, and P5 has been around, well, it was Archiware product, has been around for over 20 years. So, you know, tapes that were written 20 years ago onto LTO 2 or something like that, they're still readable by the same product that you can buy and run today. Next, just a quick recap on backup versus archive. As I mentioned, it's an important distinction. What's the difference between a backup and an archive? Well, a backup is a copy of your data. You don't delete the backup. You don't delete the original stuff off disk after you've backed it up. Whereas archive is often moving data because you want to get that space back from that completed project. Backup is DR, disaster recovery. In case you have a failure, you can get everything back. So you need to back everything up every day so that you can recover it. Whereas archive runs as needed on a selection of the data. So you tell archive what you want to archive somehow, and then you're only archiving what you told the system to archive. Maybe that's based on a search. Maybe it's like archive everything that we created in the last week. You could run it like that, but generally people are pointing at folders and archiving them. Everybody needs a backup. Everybody needs a backup. There's no exception to that. Even somebody with an iPhone has a backup. Media and broadcast companies need an archive, we've found. So maybe not everybody needs this long-term archive for media, but certainly people in media and broadcast, if they're currently trying to exist by buying USB drives, as many people that we come across are, then you need a more structured workflow to handle the archive, and that's what P5 brings to you. So with that, let's start looking a little bit at storage. So P5 target storage. Thomas, I didn't let you speak over that slide. We were going to.
That's fine.
I was going to give a pause.
I usually distinguish those two. Like backup is work in progress, which is changing every day, every hour, every minute, and archive I consider data that isn't changing over time, which means your source footage, your things you already have delivered to the client, so you can just go back to them and say, okay, I sent that out to the client on the 27th, and you know exactly what it is. Yeah. You're sure you're talking about the same file, and that kind of things. Yeah, that's the way I tend to distinguish between the two.
Yeah, I like that. So when the data stops changing, then maybe it's time to archive it, because if it stops changing, then
this might be even source footage, because it's never changing. You know, you record for raw footage on the camera, and it stays just the way.
Yeah, just archive all of it at the start of the project, and then archive again when you've done all of your edits and created all of your additional VFX and so on. So I was going to this slide next. So this was so you can do 3 different kinds of storage of P5 Archive. So P5 Archive is this piece of software. And then you could use disk to archive. Now, disk is probably the least common archive format. You're archiving from disk, but do you want to archive to disk? We've got some comparisons that might help you sort of understand that in a minute. But if you do want to use disk, sorry, I'm clicking by accident, you need to have direct attached, network attached, or SAN storage, basically anything that can be mounted as a file system within the operating system where P5 is running. You can use that to archive to. More common, tape and cloud. So for cloud, we're talking about object store type of storage. So that might be S3, Glacier, Snowball devices to get stuff into the cloud quickly. Microsoft have the Azure blob storage. Backblaze have B2. You can also send you a Fireball in the mail, so you can copy data to that and send it to populate some cloud archive quickly. Wasabi have some quite competitively priced cloud object storage. Anything that works with the S3 protocol, like Alibaba, which is a Chinese one. Google have cloud object storage. So that's all possible. You pay by the gigabyte, by the month, and you pay for various service levels depending on level of redundancy, retention, speed, things like that. or you can go your own way and you can use LTO tape. So LTO tapes are, LTO 8s are 12 terabytes of uncompressed capacity for probably about under $200. I'm not too good on pricing at the moment, but and LTO tapes can be driven by either smallish, cheapish tabletop drives or rack mount libraries where you get 25, 50, 80, 500 tapes in a single device with several tape drives there, and the robotic mechanism puts the tapes in the drive for you. So we can control that hardware, move the tapes, control the robot, remember which tapes are in which slots, all complete support for that across all different LTO generations and vendors. Okay, so moving to the next one. One of the things that has come into being recently with P5 is the ability to support LTFS volumes in addition to our traditional P5 volume format. So if you were writing backup or archive tapes with P5 up to version 6, which came out about a year ago, you would be writing the P5 volume format, which is like a proprietary format of tape which requires Archiware software to read the tape. But more recently, we introduced LTFS, which is a vendor-neutral format where basically you have a file system, that's the FS on the linear tape. So it allows the tape to have its own file system. And there are lots of bits of software that just allow you to drag and drop files onto a tape and use it like a very big USB stick or drive. So whether you choose the P5 volume format or LTFS, both formats within Archiware support both standalone drives and tape libraries. They support all of these operating systems, Windows, Mac OS, Linux, FreeBSD, QNAP. They support the spanning of large files, because often media files are pretty big, even though the tape's 12 terabytes at tops. So we can span large files across two tapes. We can use checksums to verify that what we took off the disk, it now exists on the tape identically. And you can use all the integrations, including the P5 companion, against those tapes. And as I said, if you're using a tape library, you can throw 20 tapes in a tape library and then just 20 times 12 terabytes worth of data in one go at those tapes. So you get a lot of capacity. So if you're using the P5 volume format, which is the proprietary one, you get some extra niceties. You get block level cloning, which is really useful. That means if you've got two tape drives, then you can archive your data once to those pair of drives, end up with two identical tapes. And then when those tapes are filled up, you can take one of them off to a safe location, leave one on site to restore from. So it's a simple workflow for having a redundant saving of data across two tapes by not having to do anything. You just click a checkbox in the interface when you get two tapes, providing you have two tape drives. So that's not possible with LTFS because we have to build that into our proprietary mechanisms. As well as doing the cloning, you can write two tapes in parallel for speed. So instead of getting like 300 megabytes per second to one drive, you could effectively double that by writing to two at the same time, which is different to cloning. And you can also have multiple jobs running, writing to the same tape. So you could have one archive job running, somebody else comes on to the multi-user P5 system, starts archiving some other data. Now you've got two jobs running and they can basically write to the same tape at the same time. The data gets split up and spread across the tape. So those are things that you can do with our long-standing P5 proprietary tape format. But if you want to go the LTFS route, and there are reasons to do that, like you don't want to have your data locked into a proprietary format, even though P5 has been around for a long time, as said, maybe your end user needs you to send them tapes and you need them to be able to read those tapes with some low-cost software. Maybe you have an insurance contract that means that you've got to use LTFS to archive because that's what your paperwork says that you've got to do. But either way, you can write these tapes and you don't need P5 to read them. They're in a vendor-neutral format. Anything you want to add there, Thomas?
Yeah,
As I say it.
sometimes you just get your deliverables from your the rushes from set on LTFS. You can just import them into P5, and the same if you want to collaborate with another company, you can just export an LTFS tape for them and they can read it. So you don't need to send over 12 terabyte USB drives or something like that. And because it's way cheaper with the LTFS as well.
Yeah, 12 terabyte USB drive is going to cost more than an LTFS tape, or 12 1 terabyte USB drives. So those storage options, tape, disk, and cloud, we just put these in a table so we could just talk a little bit about the comparisons between them on various vectors that are interesting. So like if we start with lifespan, so the tape manufacturers say, yeah, about 30 years. So you can put stuff on a tape, and providing you've got a drive that will read that tape 30 years later, you know, it's a long time, then the tape should be robust enough, because it's a pretty simple piece of hardware. It's just a reel of tape. So long as you keep that dry, free of dust, it's good for 30 years. Hard drives, you know, they can fail after 5 or 6 years. Around 8 years is probably a mean time. They have mechanical complexity and bearings and stuff in them, heads that are very fine tolerances. So they are great for the things that they're best at, which is the live storage, but not such a good archive format. They don't last as long. Also, they're not as, you know, they're not as well. Other columns will make the point that I was about to make, actually. I won't jump ahead. Cloud lifespan, well, this is somebody else that you're paying to spin hard disks for you. So, and if those hard disks are wearing out, part of the deal is they'll replace them before they go wrong. So the lifespan in the cloud is for as long as you want to keep paying for the cloud. If you keep paying for 30 years, and I imagine Amazon probably will still be going in 30 years, then you'll be okay. But, you know, maybe some cloud vendors aren't going to last forever. Off-site, how off-site easy is it with tape? Well, it's pretty easy, because the tapes are small, lightweight, robust enough to ship around. So you can easily take tapes and make an off-site copy of your data. Hard drives, not so easy. You get cartridge systems and ruggedized USB drives and so on, but it's not ideal. Disks are better off sitting in RAID arrays in air-conditioned data centers and so on. Cloud is always off-site. As soon as you start writing it, it's off-site. So cloud kind of wins on the off-site column. Tape, speed, as I said earlier, current Gen 8 is 300 megabytes per second write speed. So that's pretty good. It's faster than a single hard drive, I think, but not as fast as an SSD or an array. So when it comes to disks, it varies a lot with the cost with disks. USB, slow, RAID maybe fast, SSDs in a RAID really fast. Cloud, the data center storage is probably very fast, but your wide area network internet upload bandwidth will be the bottleneck. If that's slow, then you need to factor in how much you're going to archive in a given week and how long that will take to upload. If that takes 2 weeks to upload, then you don't have a solution that works, and you need to buy tape hardware or upgrade your internet connection. Reliability, well, as I said earlier, tape is pretty rugged. Excuse me. Tape is pretty rugged so long as you don't get it wet, humid, or dusty. Discs, not particularly rugged. If you drop one on the floor, then you've probably broken it, not so much with the tape. Cloud, obviously reliable. The more you pay, the more reliable service you're going to get. I think S3 have like a top tier standard, but then you can drop the amount you're paying and get less geographical separation of data, less redundancy. Tape-wise, we have quick, redundancy. Redundancy can be quite easy with tape, because as I said earlier, you can clone with P5 and get 2 tapes. So you've immediately got some redundancy. It's just up to you to separate those tapes, because if they're left in the same place, that isn't any kind of redundancy anymore, really. Disk, yes, you can achieve it. If you simply have a RAID array, then you have some level of redundancy, because you can have a drive fail. But then if the whole RAID falls over on the floor, then you don't have any redundancy anymore. So you can get better redundancy by taking tapes off site. And then again, cloud is great for redundancy, because you can just pay to make sure the cloud provider puts your data in 2 data centers like S3 standard, I think it's going into 3 different data centers in the region that you've selected. So really, you can't beat that level of redundancy. In many ways, cloud wins a lot of these things in terms of how robust the storage is. It's just the speed that's the problem and the cost. So yeah, redundancy for cloud, configurable based on cost. Cost, generally speaking, tape is high up front because you've got to buy that expensive hardware. Low incremental because tapes are quite cheap, so you can add storage cheaply once you've invested in the tape library or drive. Disk is kind of in the middle. You've got to buy that upfront hardware. The incremental cost isn't so good because you can't just put a tape in and get another 12 terabytes with disk. Cloud cost is probably overall on the high side because it's amortizing all the hardware costs and everything together into a monthly fee. There's no upfront cost, so you can start putting data in there for next to nothing. But then as you add petabytes in the cloud, you've got a big bill every month. So you have to work out if that's really what you want to do. No power costs and air conditioning, of course. That stuff is needed if you're running your own reasonably high-end disks or tape stuff. Expandability, add more tapes, easy for that. Easy for tape, more expensive for disk because adding more disks is more expensive, or an entire new array. And with the cloud, expandability is assumed because all of these cloud vendors are selling themselves on their elasticity. So you don't need to worry about capacity, you just keep throwing stuff at them and they keep charging you for it. So yeah, a lot to say going around a table like that, but hopefully that was quite informative. Anything else that we should say, Thomas?
Yeah, I think the only thing I have to add is basically the physical ownership of the storage. With tape and disk, usually you are in the possession, which means you can easily migrate it to something somewhere else later on. Or you also have no problems with, if you don't trust the cloud owner or you think about hacking or something like that, you can always put it in a safe place. But it depends on your assurance, basically, for what you do up there. Or you can do encryption with Archiware as well. That keeps you safe in terms of the data security.
Yeah, you can encrypt just in our software so that it's encrypted at source, and then everywhere it goes from there on, whether it's tape, disk, or cloud, it's encrypted and only can be decrypted when it arrives back at the host that it originally came from. Okay, so P5 archive plans, pools, and indexes. What does this mean? So the basic unit of configuration in P5 is this thing called an archive plan. So an archive plan sits there once you've configured it, and you can throw data at it. So we've got a machine over here, our source storage, and we've got files on here that we want to archive. So we need to tell P5 what we want to archive. This might be by browsing a file system. It might be by automatically archiving hot folders off of different pieces of storage. It might be using an integration, an API from a third-party tool like our companion to do drag and drop. So somehow you need to select what it is that you want to archive. And we can also you can give us a folder and we can run a filter on it to say, yeah, we're going to archive everything except for certain files, or we're going to archive a whole file system based on a date range, that kind of thing, based on metadata in files. So there's quite a lot of breadth of things you can do there. And then the archive plan itself has a pool specified within it, and the pool specifies where the data will be stored. So you could have a tape pool of storage or a cloud pool of storage. And then we also have an index where we keep track. It's a database where we keep track of every file that's been archived and stored away. So we have the two things. We have a pool that determines where we store, and we have an index which keeps track of everything that we've stored, where it is, when we did it, plus other pieces of special information about those files as well. Okay. Do you want to add anything there, Thomas?
No, you explained it pretty well.
Oh, good. I'm pleased. So let me just, sorry, I'm getting distracted. So source storage over here goes to the archive plan. The archive plan specifies the pool, which could be cloud, tape, or disk over on there. So that's the pool. And then it also specifies, sorry.
Yep. Sorry, that's the physical location. That's basically the
Yeah,
physical
yeah.
location.
Physical
Yeah.
storage. Yeah, physical storage. And the archive index, which is the database which P5 maintains, keeps track of every file that's been archived. And it does this through keeping track of the storage location. So which disk, which tape did we put the file on, which block within the tape, and so on. And then we track metadata, which is this second box. Metadata is file names, modification sizes, modification dates, sizes, thumbnails, previews, and proxies. So this basically means if it's an image, then let's make a little preview of the image so we can see that image even after it's been archived. If it's a video, then you can make a little proxy video, low resolution, maybe small length, so you've got some visual representation of what you archive so you can see it later. Metadata, captured metadata, again, we can look into the image or the video, the MPEG file, and pull out whatever metadata is there, cameras, apertures, GPS coordinates, and so on. Maybe stock images have captions embedded in them. So you can pull all of this stuff into our database as well, just so you can search and see what's in your archive before you actually commit to recovering something from the archive, because you don't want to restore stuff only to look at it and realize that it's not what you wanted. So, moving to the next one. So the storage pools are connected to the archive plan. So I could have an archive plan called Lto tape, and that one is going to Lto tapes, but I could have another archive plan which is writing to a pool called cloud, which is connected to an S3 bucket. So you can have different archive plans writing to different pools. So you've got flexibility. You don't just pick one storage media and stick with it. You can chop and change. Anything you want to add there, Thomas?
Yeah, you're totally free with the archive plan to say you want to write to the same database or to different databases or to the same pool, but to different databases. So you're with the three things are actually totally independent.
Yeah, actually, the next slide kind of illustrates that, because here I've put the we've got an archive plan which has both a pool and an index. And what I've done here is I've said maybe we are an advertising agency that are doing ad spots for Nike and for Adidas. So we create an archive plan just for Nike, which has a storage pool with 8 tapes in it, just Nike tapes. And we have a Nike database, an archive index just for that. And then we have another one called Adidas, and then we have all the same separation of tapes and index for that one. And the beauty of this is that I can then maybe log in as a Nike guy and just browse the Nike archive index with no Adidas stuff coming up at all, complete separation. So you can achieve that.
Really handy if you're working in front of a customer or something like that. Yeah.
Yeah. Or even some of our customers, they may share through the web interface, allow the customer to browse the index of, video, movies, spots, or whatever, or just assets, graphical assets for publishing. So you can browse that by having this separation. And there's a way within P5 where you can add another layer. So if we're looking at the next slide, which may look a bit weird, but you see over on the left-hand side, we've got people. So I've got 2 regular users here, and I've got 2 admin users. Over here, I've got my archive index, where I've got all the assets that I've archived in here. Now, what you can do is there's a separation between the users and the archive index called a login area. So I can create a login area for these people here that just restricts to a subset of the index, just to this part here, whereas our admin users have a login area which provides access to the whole index. So taking that a step further, we could have our Nike and our Adidas users accessing a single archive index. So they could access separate indexes, like I said earlier, but you could have one index, and you could say, I'll create a login area that just shares one folder of the index, and then the other folder for Adidas. So I've got one index, I've got 2 logins, and I've got different stuff being exposed within the same index. So those that already use P5 often, I think, don't realize you've got this level of separation under the login areas, and I'll quickly show you what that looks like within the UI now, so you get a little bit of exposure to that. Was there anything you want to add in there?
Yeah, if you're planning ahead before you write stuff out to the archive the first time with how your file system is structured, you have really a lot of possibilities in Archiware.
Yeah, so the hierarchy of our index here is created to mirror what the file system looks like. So if you keep a good tidy file system, then when you archive, you have a good tidy archive index that you know where things are going to be found. So let me just log in here again. So P5 has a web interface. This is the current version of P5. I'm logging in, and I'm going to go to the archive section here. So if I go straight to the advanced options down here, you'll see that we have a couple of archive indexes. I've got an Adidas index and a Nike archive index. So those are the databases. And then what I did is I created two archive plans. So the Nike archive plan has got the target index is the Nike index, and I've also created a separate pool for each of these. So I've got some tapes, some virtual tapes, so they're quick running, some for Nike and some for Archiware. So there's separation with the storage as well. So what that means is that when I go to restore something from archive, I can see those two indexes. I've got my Nike index and I've also got my Adidas index, and they're separate. And once I'm in an index, I can go browse down the hierarchy or the path within that index that I'm interested in. I just archive one folder off my desktop here, and then I can see within that index that I have a bunch of image files, and those image files are represented by thumbnails over here, and we have a bigger preview over on the right hand side, and I also have the caption. So some of these files have a caption which has been ingested from the file itself. We're going to look at previews and how captions work in a minute, but this is what it looks like inside of an archive index. And finally, I created a couple of users. So if I log out of here and log back in as a user called Nike, this is a non-privileged user that just has access to one of those archive indexes. So you can see by default, I'm dropped directly into this Nike archive index. But if I back up, you can see that's the only index I actually have access to. So I can only see the assets that are within the Nike index when I'm logging in as this particular user. So which slide are we on? We're on this one. So with that, we're going to drop into the next section, which I've titled P5 Minimam, Creating and Storing Previews and Metadata. So the previews and the metadata are what you saw in that web interface. So we had the ability to browse down a path. We had a list of the assets that we found in that folder. We also have a grid showing thumbnails that we've captured from these video assets in the case of this screen grab. Over on the right, we get a small video player, so we can play and scrub through. In this case, just the first 15 seconds for speed was being captured from these CCTV files. And then we have some metadata, so we've got a description, image size, codec, and duration. And these are just being captured from each of the files as they're being archived. So in here, we've got list of archive files, thumbnails of videos, playable proxy, captured metadata, and the ability to search across everything that you see below. And this is what an archive index provides you with once you have archived some media assets. You can then see everything in one place across all of the tapes or cloud storage. So I might have 50 tapes in my tape library, but I've got one point where I come in, search, see what I archived and restore. And then P5 takes care of figuring out which tapes these files that I'm asking to be restored are on, or which cloud provider, which bucket, and so on I need to connect to pull this stuff back. P5 looks after that for you. So the previews and the captured metadata that you saw there, previews on the left-hand side, I've got previews, thumbnails, and proxies. all different words for the same thing, really. These are rendered from the original file at the time of archive on the machine where that file was sitting. We have FFmpeg and ImageMagick built into P5 as tools for running the file through to extract the preview. And then the same thing goes for captured metadata. So you can capture whatever you want from the file, or you can have manually entered metadata like a client name. So maybe you just want a prompt to input a client name every time you do an archive so that you can later search on that. We support things like drop-down menus so that you're choosing from a known list of clients and stuff like that within the database as well. Things like resolution and codec can be extracted from the file. Various tools exist on different operating systems like EXIF, Tool, Metadata List on a Mac, Identify, which is part of ImageMagick, which runs on all the different platforms.
And of course, if you have your own solution, you can just tell Archiware to use this as a command line, and Archiware will call your tool or your API to extract the metadata or to retrieve the proxies. So if you have a really big encoder who does already generating the proxies, you can just guide Archiware the place where those files are stored, and we'll take those files.
Yeah, so post-production houses and VFX and stuff have lots of scriptable workflows already, and we can hook right into that. What we got here is the archive plan that you saw a little bit earlier, but there's a preview tab and there's a metadata tab. Preview tab is where we configure the preview generators. So these are just the built-in ones. We have ImageMagick handling various graphics file formats, and we have FFmpeg handling various movie formats. You can configure this all in the GUI. For capturing of metadata over on the right here, I have a simple shell script in my installation. It's just a one-line shell, a two-line shell script that just runs a tool against a file, gets the metadata it wants, and then squirts that back at P5 so it gets input into the index. And yeah, we're using FFmpeg and ImageMagick. These are pretty much industry standard, and these are also installed. So you see here where it says third-party plugins, they are part of P5. So we install up-to-date versions of both of those tools within our software directory, so it's all wired up to work without you having to do any configuration. And yeah, it's pretty useful. I'm just going to back up one slide to show you the way that this kind of works. So let's what we've got happening here is we've got a P5 server in the middle. So this is our P5 archive server. It's got some tape storage attached, so it's got somewhere to archive to. And then we have another host over here, maybe a file server, which is acting as a P5 client. So what happens here is you have P5 installed on both of these hosts. One is acting as a client, which is fairly just like a dumb data source. You don't do any configuration on P5. It's just running there so it can collect the data, and then it passes that to the P5 server so that it can actually be archived. Now what happens is the P5 running on the client, this is where our FFmpeg and our ImageMagick scripts will run. So those tools will do their work on that client machine by default. So that's worth knowing. Also, if you've asked us to do encryption, we'll do the encryption on the P5 client, so it's encrypted data that will be traveling across to the P5 server. And then the P5 server takes each file, it writes the database, the index with all of the metadata, the previews, the file names, the modification dates, and then it buries the data away on the tape, disk, or cloud storage as determined by the pool that you've got P5 configured to use. So my prompt here just says it extracts the previews and metadata on the host that is the source of the data, which is over here. So I just wanted to make that clear, because if you are archiving 6K raw video files, then obviously the generating previews, sort of proxy versions of those, will be a lot of work. So you need to factor that in and make sure that that can happen on a machine that's got the power to do it, or maybe have a script that hands that off to another machine in your render farm, which can do that transcoding.
I wanted to mention it. It's you're not limited to that kind of things. That's the default setup. It makes it really easy to generate previews. But if you have some special issues or a special setup where you need to get some CPU load off the client because it's your main storage, you're able to encode the files, the previews before or after the archive process. So you're totally free on how to do that. It's just hook into the API. There's REST and then CLI API. So it's pretty flexible. And if you need assistance, just call your system integrator or just write me an email to so we can figure something out. Yep.
Cool. Yeah, so this is like the preview generator part of the interface. It's there's like the built-in preview generators, but you can attach a script just as easily and then have something more interesting going on within your own environment. So next we'll be looking at how to use a media asset management. Not so much how to use, but just letting you know that there are integrations with media asset management products, whereby, broadly speaking, you have a media asset management product. Your workstations are talking to that with a MAM client or a web interface, and then on the back end you can hook up P5 as the engine to get stuff onto tape or stuff into cloud, maintain a database of what's happened, and then pass back references back to the MAM so it knows how to restore. Typically you'd highlight a project in your MAM, tell the MAM to archive it, the MAM tells P5 to go archive it. P5 comes back to the MAM saying, use this handle or this reference to restore, and then those assets can be shown as being offline in the MAM, so people using the MAM can see that they need to recover that data if they want to start working with it. Or maybe you retain proxies in the MAM and just use P5 to pull back the original high-res footage. So on Archiware's website, I didn't give you a chance to say anything again, Thomas. I am sorry.
No, that's fine. That's fine.
Okay. So yeah, there's a page on Archiware's site which is shown up on the screen there, where we've got all of the different MAMs that we currently support. So you might see one there you recognize: Portal, Axle, CatDV. Kino is a nice simple desktop Mac stroke Windows way of accessing footage, indexing it into a nice app web interface that will talk to P5 for archiving on the back end. Some of these things use P5's index, some of them have their own index, but we have an API, we've had it for 15 years, so we have a lot of integrations running with us, some commercial products, some in-house integrations, so you've always got that option. Now there's an integration from Archiware which is part of P5 Archive, which was new about a year ago, called P5 Companion, which gives you drag and drop archiving. So we're going to take a look at that now. So if I just click on my P5 Companion here, so this is a desktop application, runs on Mac, Windows and Linux. It's based on the Electron framework, so it's based on web tech, and it's pretty simple. You can use the burger menu over here to hook it up to the IP authentication of your P5 server somewhere on the LAN, and then you can tell it which of our Adidas or Nike archive plans that we want to use. And once you've done that, you can basically just pick up a folder of assets from the Mac Finder, the Windows Explorer, and choose to archive. So I could, for example, archive these guys at the top by just dragging them in here. Now you have to, if it's from local storage, as we are doing here, then you have to hook up a P5 client on the machine where these assets reside so it can go fetch them. Or if you're accessing shared storage, then the P5 server will go access the same shared storage that you're accessing directly so that it can get hold of those files. So yeah, I've got these lined up to archive, so I'm just going to hit next, and I could say webinar -1 as the description, and then let's go archive them. So what happens is P5 will, we're actually using disk-based archiving because it's fast, and otherwise we'd be taking a 10-minute break waiting for the tape library. So you see in the background the job finished. It shows us the job running. And what actually happened was it deleted the original files up here, and it created stub files. So for each of the original JPEGs, whatever the size of that might have been, whether it's a movie or whatever, we now have some very small files. So if we look at the size of those P5C files, they're 87 bytes. So they're actually just a little bit of metadata to tell P5 where to go find the original. So you can then have, this is optional, so you don't have to create the stub files. You could just then go browse the P5 index to locate what you'd archived via the web interface. But the P5C files, the stub files, allow restoring of those files from within the same interface without having to go use P5 at all. So I could now say I want to recover all of these files to get the originals back. So then they show up in here. Now what's cool about this is that each one of these is a file in the index, and we can go look it up. So I can click the disclosure on this file, and I can see the caption that was pulled in by P5 from the metadata in the file, also the webinar one, which is what I typed in, and I can do that for all of these files. They don't all have captions. And then when I'm happy that those are the ones that I want to recover, I just hit restore, and then P5 will start doing whatever is needed to restore those files, loading the tapes, going to the cloud storage, requesting S3 Glacier, bring the stuff back online, whatever it takes. And then if I go back to the icon view, you can see now that those files across the top are now recovered. The stub files remain in the folder because there's an option to whether you want to have those retained or deleted, but sometimes it's useful to keep those there because they would allow us to restore those files again, or I could send them to another workstation and use them to restore there. They're portable. So this is a nice simple desktop integration for P5 that allows simple drag and drop for archiving and restoring via stub files, so that users don't really need any experience with P5 to be able to get that amount of utility out of it. But at the same time, I can still go into my P5 interface and see the trainers that were archived at 1844. So that's these files at the top. You see the archive time of 1844 represents those files that we just archived from the desktop. So they go into the same index. They're restorable from both aspects, if you like. Okay. Have you had many of your customers using the P5 companion so far, Thomas?
Not yet. Basically, most of them are using their own MEM system to integrate into it.
Yeah.
Definitely makes it easier if you have a lot of operators doing the archive and restore job, because it just takes the workload of the system administrator, because a lot of times the system administrator ends up doing all the archive and restore stuff.
Yeah. Okay, cool. I see there's a few questions being typed in. I'll come back and answer those in just a couple of minutes. We're nearly through with the presentation. But if anybody's got any questions, just a reminder, type them in, and then we can look at those in a minute. So P5 topologies, on-prem, cloud, hybrid. So just 3 slides. How you might deploy P5, where you've got on-premise storage, on-premise tape, cloud-based storage, or maybe combination of both. So in this one, we've simply got P5 server on-premise, different bits of storage where we're running P5 as a client, and we can collect that to the P5 server, which can then send it up to the cloud storage, whether that's Backblaze or Amazon or whatever you want to use. So a lot of customers doing that kind of setup already. A lot of customers actually weren't using the cloud, so they maybe had a tape hardware owned and on site that they were archiving to, but why not do both? So if you have a P5 server, you just need to set up an account with a cloud provider, put some credit cards in there, and then you've got the option of archiving both to your on-prem tape LTO hardware and also to the cloud. So you've got 2 copies of your data. And then maybe you like the cloud, you have good upload bandwidth, you don't need to buy so many tapes, maybe you move in that direction, or you have a taste of it and see if you like it. Another way of thinking about it or doing it is in a cloud infrastructure like Amazon AWS EC2, you could run a Linux or Windows virtualized machine in the cloud and then not have P5 running on premise. So you take your storage systems on premise across different sites. You just need to install P5 so it's running as a background process, but then you can point those to the P5 server in the cloud and have a central archive index or indexes that you can access from anywhere. So wherever I am, I could put in a DNS name, get to P5's web interface, browse an index, and then recover data back to my host wherever I am, providing that host is set up as a P5 client. So it's a pretty lightweight piece of software to run in the background so that we can push data to wherever you are. And we even have a remote reverse IP connection facility in the product that means that the hosts on-prem push through the firewall to get to the cloud server and maintain that connection. So if there's a job that needs to transfer some data, the connection is already open. So the P5 server doesn't need to go in the other direction. You don't need to do firewall configuration and create holes in your security for that kind of setup to work. And actually, Archiware have an Amazon Marketplace EC2 instance with an Ubuntu OS plus the latest P5 version ready to fire up in the cloud. So if you have an Amazon account, I know a lot of people do these days, you can just go in the marketplace, search for Archiware, choose the size of machine that you want to deploy, and then have an IP in the cloud where you've got your P5 running and then configure it more from there. So yeah, that's the end of our slides. That good for you, Thomas?
Yeah, with the cloud installation of Amazon, basically up and running in a few minutes, and you don't even need to install it on your own server just for trying it out. Yeah, it's probably the fastest way.
Yeah, I mean, you can run P5 all day on a small Linux for a couple of bucks, and well, you probably run it all week for a couple of bucks even, and it's often quicker than installing on your own machine if you want to give a customer a demo or something. You know, it's just as easy to do that as it is to run a VM locally or install another copy of P5 on your own demo machine. So, quick slide to say Archiware will give you an eval trial license. Just go to the URL there, the download one for the download page, grab an installer of your choosing and request a demo license or speak to your local reseller. They'll give you a demo license and then get an evaluation, have a play. So let's go to your questions. Actually, I was just going to quickly show you, if you go to p5.archiware.com, here's the download page, and we have installers for all of these different platforms from Mac, different flavors of Linux. You can run us on FreeBSD, QNAP, we're in the store, Synology, Netgear, we're in the store, and here's the Amazon machine image, AMI, in the Amazon Marketplace. And you can also download the companion app on the same page. So you find everything in there. So, question time. Let's just have a little look. What's the time? We've got a few minutes left. So I've got a few questions here. So Michael kicks us off with asking, we use P5 for video project archiving, so you're already a customer. We use a manual archive process so we can manage project folders that are staged prior to archive. I want to use the proxy generation option, but I want to create only proxy files for selected assets, i.e. video masters, so we can have a visual reference on the final delivered asset for the project. I don't want to slow down the whole archive by creating proxies for everything. So basically, how do we do this? 2 archive plans? Would this approach create a second index of assets? Thomas, do you want to take this one?
Oh, you could probably do a filter just for the proxies. So you could tell the proxy generator to filter the path or some pattern inside your file name.
Yeah.
And that's probably the most direct route to go. Or you could go with two archive indexes, two archive plans, and use the filter option for file filtering, which is a bit more extended than the wildcard filtering in here.
Yeah, because within the actual preview generator, within the archive plan, which is what I'm just showing you here, you can have different preview generators for different file extensions. So if you can isolate the files that you want to have as previews generated for by file extension, then you can do different things for different file extensions. So that would be really simple, because you can have as many different preview converters in this list as you want, each handling different file extensions. But then other than that, you need to have a filter, I think, on the archive plan that will select the assets that you are interested in, and then run an archive plan that has the preview generation switched on, but has a filter set up for a subset of the assets. The filter menu is blank here because I haven't created a filter yet, but if I go down to advanced options, which hasn't shown me everything, right, file filters, and then if I create a new file filter called X, you can just select files matching an expression, and you build the expression by saying, well, my file name ends with or starts with, or my path contains some string, or modification dates are within a certain range, or size is bigger or smaller than some figure that you specify. So yeah, one of those should get you a long way towards where you're looking to be. Michael, hopefully that helps. If not, you can ask follow-ups. Can you drag folders into the companion? Yeah, you can. I should have done that actually. So I could just pick up the entire trainers folder. I need to have the right tab open in here. So if I go to archive, and then I just use a little proxy icon, I drag that in, then I've got trainers here, and that will archive the whole folder. So if I do that, actually, you'll see all of those files will disappear in a second, get replaced with the P5C stub files. So that's a yes. Chris asks, does it support virtual tape drives? So yeah, it does. You can either you can either use disk to create virtual tape drives within P5 itself. So we have the concept of a disk library. So it's basically P5's own VTL. We write into container files that we compress on any disk storage that you want us to, and we treat everything just like tape. Yeah, VTLs, yeah, we support hardware VTLs. So this is where you've got some kind of hardware appliance that is actually full of disks, but it behaves like a tape library and responds to the same SCSI commands that a tape library responds to. So yeah, either of those things possible. Hopefully that answers that question. Is P5 tar compatible for extracting media externally? Internally, P5, when it's writing the proprietary tape format, uses something called CPIO. So it's not like entirely proprietary, because CPIO is much like tar. But in addition to saving the data, we have ways of saving our indexes and Unicode file names and so on. That is because we have a very good Unicode file name support cross-platform. We add quite a bit of extra information in that might, has to be interpreted correctly when reading the data back off the tape. So it would be difficult to write something like a tar routine for extracting the media off the tapes. LTFS obviously is different ball game. Those tapes can be read by third-party systems, so that's not a problem. Question from Mike. Can I archive a subset automatically of my data? So Thomas, do you want to go with that one?
Yes. Yes, we have already been to the page where you did show up with the filters. Here you can define a filter based on a pattern, or in the archive plan where you can select a dedicated root location where you can specify a certain folder. in here you could,
something like that. So you could
something
define,
like that. If you,
yeah,
or the things you, maybe your rushes, which is basically everything which came into onto the storage the last 24 hours or something like that, and you don't want him to parse all the file systems, so go into your archive plan and say, okay, that's just in that folder, in that location. Want to show that?
Yeah, so the archive plan, so you would attach the filter. I didn't save it, so it doesn't show up in the list. But then, yeah, you configure auto archiving. So from however many client machines you've got configured in your infrastructure, you can specify one or more directories, and then you can have a scheduler that is configured to do archiving every 6 hours or once per day between at a particular time of day on particular days of the week, or even just monthly on a certain day of the month. So you can have an automated archive that runs on its own against known folder list and then filters what it finds at that location based on the file filter that you've specified. So, for example, I know a customer who does not archive, is archiving Final Cut Pro projects, but avoids certain folders within the project structure because those folders contain generated proxy media that can be regenerated later if it needs to be. So rather than adding to the storage costs, they just will regenerate the files as they need them if they need to work on a project again. Yeah, okay. So we've run to time again. It's 1 minute past 7 in the UK. So I think we answered all the questions. So yeah, thanks everybody for attending. Thanks Thomas for being here as well and introducing yourself. So Thomas's contact details will be in the email slides that we'll send to you, plus a YouTube recording. Yeah, so thanks for coming. Hope you enjoy this Webinar Wednesday series. We're open to requests if there's something in particular that you'd like to see. So we'll see you at the next webinar. Thanks again, Thomas.
Thank you, Dave. Bye.
Bye. Bye, everybody.